Okay, let's get started with 6-6. Just to give you some tips if you need a summary of what we did in class, there are some math notes, and they are in lesson 6.1.3. So if you're using the ebook, you could go to that lesson, and if you scroll down to right before where the homework starts, there are some math notes that summarize what we learned about special right triangles in class on Monday or Tuesday. So remember that this is half of an equilateral triangle. If you take this triangle, reflect it over the longer leg, you're going to get an equilateral triangle. So this side would be the same as this side would be the same as this side. So that means if you're just looking at the 30, 60, 90 triangle, the short leg is always going to be half. X is half of 2x. The hypotenuse is always double the short leg. And then if you do Pythagorean theorem and simplify, and the simplification is why you don't have con for this particular lesson. There's quite a bit to the simplification. In fact, if you look at the math notes from the lesson 6.1.1, it shows how to rationalize the denominator, and we'll probably have to do this as like a side lesson at some point because it comes up, and your teacher next year may not expect you to have mastered this, but probably expect you to have seen it. So anyway, that's why we're doing paper and pencil homework. Another pattern that we noticed was for 45, 45, 90 triangles. Those are isosceles right triangles. These are the base angles. These are the two sides that are equal. So these are always the same. And then if you do Pythagorean theorem a few times, you're going to notice, oh, hypotenuse is always whatever that leg is times the square root of 2. Okay, so let's start with 6-6. It says to use right triangle patterns to determine the missing side lengths, then calculate the area and perimeter of each triangle. Okay, well, this is a 45, 45, 90 triangle. Even though it didn't give me 45 right here, I can easily figure that out. Add these two together, subtract from 180. This is 45 degrees. So then these two sides are equal. So this must be square root of 2. And in a 45, 45, 90 triangle, the hypotenuse is equal to the leg times the square root of 2. So this hypotenuse is going to be the leg, which happens to be square root of 2, times square root of 2. And the square root of 2 times the square root of 2 is 2. Part B, we have a 30, 60, 90 triangle. It doesn't give me that this is 30, but I can figure that out. And I know that the hypotenuse is 10. In a 30, 60, 90 triangle, the hypotenuse is equal to, it's always double the short leg. So I know that this leg is going to be 5. And the longer leg is always the short leg times the square root of 3. So this longer leg, you have a short leg and a long leg. The triangle in a triangle, the sides that are across from the angles, they correspond. So the smaller side is across from the smaller angle. The longer leg, or the longer side, is across from the larger angle. The biggest side, the hypotenuse, is always across from 90 degrees. You can't have an angle that's bigger than 90 in the triangle. So then my short leg is 5, and my long leg is 5 square root of 3. Okay, 6, 7, written the conjectures below. For each one, decide if it is true or not. If you believe it's not true, provide a counterexample, an example that proves that the statement is false. If a shape has 4 equal sides, it cannot be a parallelogram. So think about that. 4 equal sides. It cannot be a parallelogram. So if I have 4 equal sides, I'm either going to be, I know most people are going to think, oh, it's a square. And squares have 4 equal sides, but so does a rhombus, which is hard to draw and not make it look like a square. But you can have 4 sides and not have 90-degree angles. So this is saying it cannot be a parallelogram. There's no way to draw a quadrilateral with 4 equal sides and have it not be a parallelogram. A square is a parallelogram, and a rhombus is a parallelogram, and they both have 4 equal sides. So that statement for part A is false. Part B, if the tangent of theta is more than 1, then theta must be more than 45. Okay, so let's think about this. Remember, tangent, if the tangent of theta is greater than 1, then theta must be more than 45 degrees. Tangent is, remember this, it's the slope, the rise over the run. And then later we learned it's the opposite over the adjacent, but at first we learned it was the rise over the run. So if this is bigger than 1, that means that the rise must be bigger than the run. So you're looking at something maybe like this, where the rise is greater than the run. So if the tangent or the slope is greater than 1, is the angle going to be bigger than 45 degrees? Well, think about it. I don't know if you remember this when we did that chart and it had all the angles and it had an example of the slope of each angle. If you have an angle of 45 degrees and you're looking at the slope, then you're looking at a 45, 45, 90 right triangle. And a 45, 45 right triangle has 2 sides that are equal. And if I look at this side divided by this side, it doesn't matter what the length of each one is, whether it's 1 over 1, 2 over 2, 3 over 3. That slope, the tangent, is going to be tangent, let's put tangent 45, is going to be equal to 1. So yes, this is a true statement. If the slope is bigger than 1, then the angle must be bigger than 45 degrees, because as this gets bigger, think about it, the slope is just going to get bigger and bigger, steeper and steeper and steeper, and the angle is going to get bigger than 45 degrees. So that is a true statement. Let's see, part C, if 2 angles formed when 2 lines are cut by a transversal are corresponding, then the angles are congruent. Okay, this is going back to chapter 1. If you have 2 formed when 2 lines are cut by a transversal. Here's one example. All this says is that if you have 2 angles form when 2 lines are cut by a transversal, if 2 angles form when 2 lines are cut by a transversal are corresponding. Did not say that they were congruent. That's kind of a trick question. But if these 2 angles are corresponding, well, just because they're corresponding, it doesn't mean that they're congruent. These corresponding angles are congruent. Can you fill in the blank here? If the lines are parallel. They're only going to be equal if these two lines are parallel. Okay, 6-8 is leading into the latter part of this chapter. Simplify each of these expressions. Your final expression should contain no negative exponents and no parentheses. Okay, part A. Okay, we are going to multiply the coefficients. So I'm going to do -10 times +2. Which would give me -20. And then when I multiply powers, when I multiply exponents, I add them. So a to the -1 times a to the 4th is a to the 3rd. And then b is just out here by itself. So this said to simplify it, so there's no negative exponents and no parentheses. That's it. Part B. When you are raising a power to a power. So this means, think about what this means. It means 3x to the 4th times 3x to the 4th y times 3x to the 4th y. If you're squaring it. Okay, I'm going to multiply my coefficients. 3 times 3 is 9. And then I'm going to add the exponents. Multiply x to the 4th times x to the 4th. I get x to the 8th. Y to the 1st times y to the 1st is y to the 2nd. Now this one's easy enough. If you didn't understand it, you could just write it out. That means three x to the 4th times y times 3x to the 4th times y. How many x's do you have? 8. 3 times 3, there's 9. Y times y, there's y to the 2nd. I'm tempted to write this one out for you, but I'll skip over it. I don't want the video to be too long. Okay, 4z to the 5th. Okay, here's a good one. 2z to the -2nd. So a lot of students think because it's got a negative exponent, it has something to do with the answer being negative. That is not true. A negative exponent is just shorthand for, and this I am gonna explain a little bit. It's just shorthand for saying that this base is in the denominator with this exponent. What does that mean? Okay, here it is. Pay attention so that you understand this. If I have to the 0 power, anything to the 0 power is 1. And if you didn't remember that, you could start with z to the 1st power. Z to the 1st power is z. And actually, let's do, instead of z, let's do 2. So 2 to the 0 power is 1. If you didn't know that, you could do 2 to the 1st power, that's 2. 2 to the 2nd power is 2 times 2, which is 4. 2 to the 3rd power is 2 times 2 times 2, which is 8. Okay, well what about 2 to the -1 power? Okay, well let's look at this. We've got a pattern. You're multiplying by 2 to go forward, right? What about going backwards? You're dividing by 2. 8 divided by 2 is 4. 4 divided by 2 is 2. 2 divided by 2 is 1. So what am I going to do here? You said it correctly if you said 1 divided by 2. Okay, well what about 2 to the -2? Okay, well that's just going to be 1 divided by 2, 1/2, divided by 2, which is the same as divided by 2 over 1, which is the same as 1 over 2 times 1 over 2. You probably did copy dot flop in middle school. And that's 1/4, which could be written as 1 over 2 squared. Are you starting to see a pattern here? This is 1 over 2 to the first. This is 1 over 2 to the second. What do you think 2 to the negative 3 is going to be? If you're not sure, you could work it out. You could say, well, I know it's going to be 1/4 divided by 2 over 1, which is times 1 over 2, 1/8, which is 1 over 2 to the third. Do you see the pattern? 2 to the third, 2 to the negative 3. 2 to the third is 8, 2 to the negative 3 is 1 over 8, 1 over 2 to the third. That negative has nothing to do with an answer being negative. It's just shorthand for saying this base is in the denominator with this exponent. Kind of a strange way to do it, but once you get the hang of it, it's not too bad. So if you forget, hopefully you've written this down and you can keep this and come back to it if you need it. Okay, so for part C, we have 4z to the 5th over 2z to the negative 2nd. I'm going to write this out and then I'll do the shortcut. That is z to the 5th. Okay, and this is divided by 2z to the negative 2nd. So I'm going to write it like this, divided by, and then I'm going to write, well, maybe I'll write it down here. Okay, this is 2 over z to the 2nd. 2 is in the numerator. Z to the negative 2nd means 1 over, this is the same as writing 2 times 1 over z to the 2nd. So that's 2 over z to the 2nd. Okay, so now we've got 4z to the 5th, okay, divided by 2 over z to the 2nd, which is going to be times the reciprocal. So times z to the 2nd over 2, which is going to give me sorry, I was going to put a 1 under here. That's going to give me 4z to the 7th, because I've got 7 z's, over 2, and then I can do 4 divided by 2, which is 2, so 2z to the 7th answer. Now, if you know the rules for dividing exponents, you just subtract. 4 divided by 2 is 2. 5 minus negative 2 would turn into 5 plus 2, which would give me 7. So you could have just done it with the shortcut. Okay, 6-9 says to solve the quadratic equation below twice, once using zero product property and once using quadratic formula, and verify that the methods are the same. Okay, let's try zero product property first. So zero product property means I need to replace y with 0. That has already been done. The equation when I started was this, and they have already replaced y with 0. So now I'm going to try factoring it using an area model. My x squared term and my constant go in opposite corners. I multiply them to get the top of the diamond. I put my x term on the bottom of the diamond. So let's see, what can I multiply to get 18, but when I add it I get 19? Hopefully 1 and 18 just popped into your mind. So 1x and 18x will multiply to give me positive 18. If they're both negative, they will still multiply to give me positive 18x squared. But when I add them, I'll get negative 19x. So we have negative 1x and then negative 18x. Okay, let's go ahead and find the length and the width. We know this is going to be 2x and x, and 2x has to go here because it's a factor of this every term in this row. So 2x is here, x is here. X times what is negative x? 2x times what is negative 18? So then as a product, this would be 2x minus 1 times x minus 9. And I'm going to use zero product property. If these two quantities multiplied together give me 0, then either this must be 0 or this quantity must be 0. If 2x minus 1 is 0, add 1 to both sides. Divide by 2. So x equals 1/2. Add 9 to both sides and I get x equals 9. So these are the two x-intercepts. Now it said to use quadratic formula and see if we get the same thing. All right. For quadratic formula, a is 2, because remember, standard form of a quadratic equation is ax squared plus bx plus c. So a is 2, b is negative 19, c is 9. All right, let me write that down here. Quadratic formula is x equals, and remember you do need to do this consignment. You only need 75%, but I'm doing that. I mean, your teacher next year is going to probably use it at some point. You don't want to be completely lost when your teacher is doing this. So x equals negative b plus or minus square root b squared minus 4ac divided by 2a. Opposite of b, if b is negative 19, the opposite would be positive 19, plus or minus square root b squared. I'm just going to go ahead and square negative 19. What is that? Let's see. And the reason I don't write negative 19 squared, I'll show you because you can see this really well. If I type in negative 19 squared without putting negative 19 in parentheses, I'm going to get negative 361, but that is not the answer. Negative 19 times negative 19 is positive 361. So if you wanted to use a calculator, you would need to put the number in parentheses. Calculator's only going to do what you're telling it to do. Minus 4 times 2 times 9. Okay, divided by 2a. 2 times 2 is 4. So let's see what we get here. We have, I was encouraging you to put this part in the calculator just because that's where students tend to make a mistake. So let's go ahead and do that. Okay, that's 289, which is a perfect square. The square root of 289 is 17. So this turns into x equals 19 plus or minus 17 divided by 4. That's two answers. That's 19 plus 17 divided by 4. And then 19 minus 17 divided by 4. 19 plus 17 is 36 divided by 4 is 9. 19 minus 17 is 2 divided by 4 is 1/2. Does that match what we got earlier? It sure does. So quadratic formula will always work. Okay, 6-10, rewrite each formula as indicated below. I've seen some of you doing some assignments like this for SAT practice, and it's not really that hard. It just takes a little practice. Okay, the distance an object has fallen under the force of gravity is given by d equals 1/2 g t squared. Solve this formula for t, for time. Okay, I'm trying to get t by itself. I want to get rid of this, I want to get rid of this, and I want to get rid of that squaring. So I'm going to go from the outside in. When you are undoing a problem, you go in the opposite order for your order of operations. So normally you would multiply, you would do your exponents and then you would multiply. Here we're going to undo the multiplication by dividing first. So the opposite of, I'm going to get rid of 1/2 by multiplying both sides by 2/1. That's going to give me gt squared equals 2d. Then I'm going to undo this multiplication, the multiplication with g, by dividing both sides by g. So that gives me t squared equals 2d over g. And then I'm going to do the opposite of squaring, taking the square root. So t equals the square root of 2d over g. Next one says area of a circle is pi r squared. Solve this formula for the radius r. So let's get r by itself, kind of the same concept. Let's get rid of the multiplication by pi by dividing both sides by pi. So that's going to give me r squared equals a over pi. And then the opposite of squaring, take the square root. So my answer is going to be r, the square root of a over pi. Okay, 611 we have determine whether or not the two triangles in each pair below are similar. If so, create a flow chart. If not, explain why not. Okay, we might skip over the flow chart. Let me see. Let me quickly sketch this. I think I'm going to skip the flow chart. Let's just say if they're similar. So I do want you to draw the diagram. It's been a while since we've done something like this. It's good practice. Okay, there are 3 shortcuts for similarity. If triangles are similar, the definition of similarity is that it's a dilation. The angles are going to be the same. The sides are in proportion. So it's just one's a dilation of the other. Well, let's look and see what we have. We've got angle B is equal to angle E. We've got these two angles are vertical angles. Do you remember those? Let's just put a 1 and a 2 and say angle 1 is congruent to angle 2. So guess what? If you've got 2 angles in one triangle equal to 2 angles in another triangle, you know that that third angle is going to be equal to that third angle, and that's really all you need. So we know that, I don't even have to write that out, that triangle ABC is similar to triangle. Now let's get the order correct. A goes with D, so D has to go first. B is congruent to E, so DEC by, and we just use the angle shortcut. Okay, part B, we have some parallel lines in part B. So let me give myself a little space. If these two lines are parallel, we've seen this many, many times. You've got parallel lines cut by a transversal. That means that these angles, these 4 angles here, are going to match these 4 angles here. This angle, angle W, is going to be the same as this angle, and it's also going to be the same as this angle. If you took tracing paper and you slid this angle over here, you would see that these two are the same, and then these are vertical angles, so they are the same. Okay, so then we have a pair of angles that are congruent here. We have another pair of angles that are congruent here, vertical angles. So let's see, we have angle W is congruent to angle Y. Let's just do 1 and 2. Angle 1 is congruent to angle 2, and that's all I need to do. We could say that these are equal, but we already have 2 pairs of angles. That's all we need. Triangle X, W, Y, X, W, Y is similar to triangle X. These 2 angles are the same, so X has to go first. W corresponds to Y. Oh, I think that's a V. That's a V. XWV. And then XYZ. By angle, angle again. By the way, this last one could have been, let's see, if you look at the sides that include these 2 angles, we could have used SAS, I think, because if you do 8 divided by 12, let's see, you should get the same thing as 18 over 27. This reduces to 2/3, and then this reduces to 2/3. So we could have used side angle side on this one. Either angle angle or side angle side would work, but if we did side angle side, we'd have to show this. Okay.